So in this problem, we have to show that in a triangle ABC, using the law of sine, this particular equation holds true. So let us begin. So first, let's start from the left-hand side. So we'll begin by noting down the terms that we have. Now what we'll do, let's use the law of sines. For that, we need a triangle. So A could be any triangle. It could be an acute triangle, acute angle triangle, it could be an obtuse angle triangle, or it could even be a right angle triangle. But for simplicity, let's use an acute angle triangle with vertices A, B, and C. We're also going to specify its side. So if we consider angle A, then the side opposite to it, which is represented by BC, we're going to call it A in lowercase. Then we're going to consider the next angle, which is angle B, and the side opposite to it, which is AC, going to represent it by the lowercase letter b. And then finally, side AB, which is opposite to that of angle C, we're going to represent it by the lowercase letter c. Then the law of sines. The law of sines, so it states that if we take the ratio of the side A to that of the sine of the angle opposite to it, which is angle A, so this ratio will be equals to the ratio of the side B to that of sine of the angle opposite to it, which is B. Similarly, this will be also equals to the ratio of side C to that of sine of the angle opposite to it, so that's C. Now, in the law of sines, in order to solve this problem, what we'll do, we will consider that let these three ratios be equals to a common constant lambda. Now, once we do that, what we can do, we can rewrite A as lambda times sine A. Then B can be expressed as lambda times sine B. Similarly, C will then become lambda times sine C. So we're going to replace A, B, and C with these three values, lambda sine A, lambda sine B, and lambda sine C. So let's do that. So here we have A squared. So in place of A squared, we have lambda squared multiplied to sine squared A. But we're going to rewrite sine squared A as sine A times sine A. This will become evident in the next step, but for the time being, let's write it down in this particular fashion. So we've multiplied to it is sine B minus C, whole divided by sine of B plus sine of C. Coming to the second term, we have B squared. So in place of B squared, we're going to use lambda squared times sine squared B. The sine squared B can be also written as sine of B times sine of B multiplied to sine of C minus A whole divided by sine of C plus sine of A. And we have our third term. In the third term, we have C squared. So C squared is represented by lambda times sine C. We're going to get lambda squared multiplied to sine C times sine C multiplied to sine A minus B whole divided by sine A plus sine B. Fine. Now, let's try to understand the reason of writing the product sine A times sine A instead of sine squared A. Now, we know that in any triangle, the sum of the interior angles, that's 180 degrees. So A plus B plus C, so that's equals to 180 degrees, or we can also represent it by pi radians. Then A will be equals to lambda minus B plus C. Now, if we take the sine of the angles on both sides, so sine of angle A will be equals to sine of pi minus B plus C. Now, we know the value of sine of pi minus B plus C, that simply equals to sine of B plus C. So we can say that sine of angle A becomes equals to sine of B plus C. That's the reason why we split sine squared A into sine A times sine A. Now, using the same idea, we can also say that sine of B, that will be equals to sine of C plus A. Then sine of C will be equals to sine of B A plus B. Fine. We will be using this value and replacing one of the sine A, only one of the sine A, with the respective value. So let's do that. So beginning with the first one, we have lambda squared. So let's keep the sine A, one of the sine A as fixed, and the other sine A, which is this one, we'll be replacing with sine B plus C and multiplied to sine B minus C whole divided by, we have in the denominator sine B plus sine C. Then coming to the next term, we have lambda squared multiplied to sine B. Now, the next sine B will be replaced with sine C plus A. So we have sine C plus A multiplied to sine c minus a whole divided by sine c plus sine a. So that's the denominator portion. Now we can also write the third term. Our third term will become lambda squared times sine c. Then the next sine c will be replaced with sine a plus b. And we have sine a minus b multiplied to it. And in the denominator, we're going to have sine a plus sine b. Fine. Now the whole reason why we wrote in this particular fashion, because now we have in the numerator of the first term lambda squared times sine a, the product sine b plus c times sine b minus c. So that's actually the factorization of, or the expansion of, sine squared b minus sine squared c whole divided by sine b plus sine c. Then coming to the next term, we have lambda squared multiplied to sine b, and the product sine of c plus a times sine c minus a. So that is the expansion of sine squared c minus sine squared a whole divided by, we have sine c plus sine a. And then in the third term, we're going to have lambda squared times sine c, and the product sine of a plus b times sine of a minus b. So that will be sine squared a minus sine squared b whole divided by sine of a plus sine of b. Now, the good news is sine squared b minus sine squared c, so that can be also represented as lambda squared times sine a multiplied to, so we have sine of b minus sine of c multiplied to sine of b plus sine of c divided by sine of b plus sine of c. So this can be done to the second and the third term as well. And in doing so, we can immediately see the sine b plus c from the numerator and the denominator factors out. So we'll be only left with lambda squared sine a multiplied to sine b minus sine c. So this could be done for the two terms as well. So let's write down in the next step. So we're going to get lambda squared multiplied to sine a whole multiplied to sine b minus sine c. So this is going to be the first term. Then after factorization, after factoring out the common term from the numerator and denominator, the second term will be sine lambda squared times sine b multiplied to sine c minus sine a. And the third term will be lambda squared multiplied to sine c multiplied to sine a minus sine b. Now what we'll do, we'll take lambda squared as the common factor from each of the three terms and then combine the remaining. So we have sine a multiplied to sine b minus sine c. So that's sine a multiplied to sine b minus sine a times sine c. Then in the second term, we have lambda squared taken out already. So we have sine b multiplied to sine c minus sine a. So we're going to get sine b multiplied to sine c minus sine b multiplied to sine a. And then coming to the final term, we have sine c multiplied to sine a minus sine c multiplied to sine b. Now clearly we'll see here that some of the terms will get cancelled out. Let's start with the first term. We have sine a times sine b. So this term and this particular term cancels out. We have negative sine a times sine c. So this term and this term and this term. So that turns out all the terms within the parentheses cancels out, leaving us with 0. So we have lambda squared times 0, which is simply 0, and this is the right hand side. So hence we were successfully able to show using the law of sines that this particular expression equates to 0.